Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding and you can understand concepts in a better way. So next time, you can do these questions by yourself. Let's study together. Let's improve together. In today's class, we are talking about October-November 2022, Paper 1, Variant 1. And total time for this exam is 1 hour and 15 minutes, and total mark for this paper is 40, and there are 40 questions in this paper. So it simply means that we have 75 minutes in total, and there are 40 questions. So you have about 1.8 minutes per question, means for each question. But this is not to just spend 1.8 minutes on each question. You need to understand some smart ways to answer multiple choice questions in exam, means under time conditions. So the best way to approach these questions is, first of all, go through easy question, mean the question you look at them and you can find the answer. So you can answer those questions first of all, and then you can come back and you can start working on hard questions. And don't stuck with one question. For example, if one question you can't figure out the answer, you can try to find answer by elimination method. You can eliminate the options that are not possible and you can choose the best possible option. So you should not just stuck with one question. So very important. And how you can improve your techniques or your methods to answer questions in exam, at least 1 month before exam, you can start solving past paper by setting time. Means try to do paper in 1 hour only. 1 hour, not in 1 hour and 15 minutes. On next page, you can also see some data, means values of some constants are given to you. If you need value of any constant for some calculations in your exam, you can come back to this page and you can find the values. On the next page, actually is on the same page, some formulae are also given to you. So these formulas are not all formulae you need for AS physics, but some of formulae are given to you. So if you have forgotten any formula, you can come back to this one and you can recheck. But it is better as a physics student, it's very important if you can remember them, or you need to understand how to derive these formulae. So that is the best thing, because you will need these formulae for your whole life. I mean, when you go to university, you also need these basic formulae. So it's better to remember them, and also you need to understand how to derive these formulae, because when you derive formula, if you understand how to derive a formula, it means you have better understanding about physics concepts behind that formula. So always try to understand how to derive formulae. Let's go to next one and start working on questions now. For question number 1, it is given to us what is needed to accurately represent all physical quantities. So first of all, we need to understand what is a physical quantity. A quantity that can be measured, we can call is a physical quantity. A quantity that can be measured, we can call that quantity is a physical quantity. And most of the physical quantities, they have unit. Most of the physical quantities, they have unit, and also they have numerical magnitude. So they have unit and also they have numerical magnitude. Most of the physical quantities, they have unit and they also have numerical magnitude. But physical quantity like strain, means strain is a ratio between two same physical quantities. So strain has no unit. But most of the physical quantities, they have unit and they also have numerical magnitude. So when we represent physical quantities, we use unit and numerical magnitude. So physical quantities, they have unit and they have numerical magnitude. So this is the point you need to understand. Now if you look at first option is given to you is a base unit and a number. So that is not possible. Not a base unit, it can be a unit, not base unit. Number is not good, it has to be numerical magnitude. A unit and a number expressed in standard form, we no need to express physical quantities in standard form. So this is also not possible option. A unit and a numerical magnitude. So this one is best possible answer. So this is our answer. An SI unit is not required. You can use any unit that is not even part of SI system. And a numerical magnitude. This is right, but this is not required. It can be any unit we can use for physical quantities. So the answer for this question is C, and this is what you need to understand. How do we represent physical quantities? We represent them by unit with numerical magnitude. For example, we have 5 kg, so we have 5 kg. So this one is the unit. So this one is unit and this is numerical magnitude. So this one is numerical magnitude. Numerical magnitude. This is numerical magnitude. And also, let's say we have 6 newtons. So this is representing force. So this is numerical magnitude. So I can say this is numerical magnitude and N is the unit. So physical quantities are represented by unit and numerical magnitude. So this is what you need to understand. But physical quantity like strain has no unit because it's a ratio between two same quantities. For a second question, it is given to us a voltmeter connected across a resistor in a circuit reads 3.6 volts. What could be the current in the resistor and the resistance of the resistor? So in this case, V is given, potential difference is given to us. If you want to sketch this one, so simply you can also sketch in this case. So this one is resistor. So we can say this one is resistor. And voltmeter is connected across this one. So you can imagine this one is the voltmeter. And the reading of this voltmeter is given. Then that reading is equal to 3.6 volts. Now question is asking us what is the value of I and what is possible value of R, possible value of R. But we need to understand potential difference across this resistor is equal to the product of current passing through this resistor and resistance of this resistor. So simply we need to multiply these two quantities and we need to find out which one is equal to 3.6 volts. So first of all, you can multiply these two. So we have 150 milliamps. So you have to be careful with units. And here we have this is 0.24 times 10 to 3. So this we can simply cancel. And if you solve this one, you will get in this case 36 volts. So this is not possible answer. So we can also go to the next one. You can try next one. So in this case, you have 15 times 10 to minus 3 times you have 2.4 times 10 to 3. So if you multiply these two quantities, so as it was cancelled here, so these powers will be cancelled and these powers also will be cancelled. So if you multiply 15 with 2.4, you will get this is 36 volts. Now we can go to next one. So you have to repeat the same process, simply I times R, and this is 10 to minus 3 times we have mega. This is 0.24 times 10 to 6 mega. So in this case, your answer will be 360 volts. So this is also not possible answer. So we can go to the last one. So this one has to be the answer. So this is not possible answer. This is not possible. This is not possible. So this one has to be the answer. So if you multiply 15 microamps, this is 10 to negative 6 multiplied by 240 times 10 to 3. So you will get final answer. That one will be equal to 3.6 volts. So this is the answer. So main concept in this case is simply you need to understand potential difference across a resistor is equal to the product of current passing through resistor and resistance of resistor, and you can figure out. So answer is D. For our third question, it is given to us in an experiment to determine the acceleration of free fall g, the time taken for a ball to fall through a distance s is measured. The percentage uncertainty in the measurement of s is 2% and percentage uncertainty in the measurement of time is 3%. The value of g is determined using the equation shown. So we can use this equation and we can calculate value of g. and we need to find out what is the percentage uncertainty in the calculated value of G. So the first thing we need to understand, in this case, G is equal to 2S by T square. So these quantities, they are multiplied and divided. So when quantities are multiplied or divided, percentage uncertainties are added. So in this case, simply we can say delta G by G. So this is the percentage uncertainty in G. That one has to be equal to the percentage uncertainty in S. So we can say that has to be equal to delta S by S, means the percentage uncertainty in delta S plus percentage uncertainty in T, means delta T by T, and this one has to be multiplied by 2 because the power of T is 2. And now simply we can use the values given to us. For S, percentage uncertainty is given, that is 2%, and percentage uncertainty for time is given, that is 3%. So we can write down this one is 3%. So the final answer we will get, that is 8%. So this is the percentage uncertainty in calculated value of G. So the point is that you need to understand when quantities are multiplied or divided, percentage uncertainties are added, and we no need to consider this scale factor. Even if we consider ratio will be the same, because ratio will be the same, so we no need to consider this scale factor. So this is how you need to approach this type of problems. For question number 4, simply we need to find out which quantity is a vector quantity. Momentum is a vector, so this can be the answer, but speed is not vector, temperature is not vector, Young's modulus is not vector because it's ratio between stress and strain. So the answer for this question is a very straightforward question. For question number 5, it is given to us a particle accelerates from rest. The graph shows the variation of the velocity v of the particle with time t. So in this case, if you look at this graph, we can see the gradient of this graph is constant, and gradient of this graph is equal to acceleration. So gradient is equal to acceleration, and acceleration in this case is constant. So this is the first thing we need to understand. Acceleration is constant because gradient is constant and gradient is representing acceleration. Now we need to find out which graph shows the variation of the velocity v with acceleration of the particle. And acceleration in this case is constant, mean acceleration is not changing with time, but speed is increasing with time. If we look at option A, this is telling us acceleration is increasing, but that is not possible because acceleration has to be constant. This is also telling us acceleration is increasing with velocity, so that is also not possible. And this is telling us velocity is constant, but acceleration is increasing, that is not possible. So only possible answer for this question is A, because acceleration is constant, then velocity is increasing. So the answer for this question is D. So you need to read question carefully. You need to understand what is given to you and how you can figure out the answer. So in this case, this graph is very important because we have velocity against time graph, and gradient of this one is constant, and gradient is representing acceleration. So acceleration has only one value. So that's the reason our answer is D. For question number 6, it is given to us the graph shows the vertical velocity of a parachutist during first 20 seconds of her jump. Approximately, we need to find out how far does she fall before opening the parachute. Before opening the parachute means she is opening parachute at this point. So first thing, we need to mark this point. So she is opening at this point. Now we need to find out the distance, and we have velocity against time graph. So simply we need to calculate area under this graph. So simply, first of all, we can draw this line here, means we need to find out area. This area we need to figure out, this area, and we can divide this area into two parts. We can simply divide this area into two parts. One part we can draw this rectangle, and we can also draw a triangle. So this is the triangle. Now we need to calculate this area. So first of all, we will try to figure out this area. So this one, this area we will try to calculate, and then we will try to calculate this area, this one. So let me use this color so you can see which area we are calculating. So this area of triangle we need to calculate. So this area of triangle we will calculate, and area of rectangle. So this area of triangle. So we need to calculate area of triangle and area of rectangle. So let me use a different color for the second area. So this area of rectangle we need to calculate. So this area of rectangle. So these two areas we need to calculate, and then we can approximate distance. So these two areas. So first of all, in this case, we will calculate area of triangle. So area of triangle, or simply we can say, in this case, distance will be equal to area of triangle plus area of rectangle. And in this case, area of triangle, we have 0 here, and this is 10, and here we have 60. So simply this is 1 by 2 times 10 times 60, and area of rectangle, we have 10 here, so this is 11, 12, 13. So this is 13. So we have 3 times 60, and if we simplify, we can cancel this 2 with this, we will get 5 here, and we can multiply, we will get 300 here. And if we multiply 60 with 3, we will get this is 180. So the total area is equal to 480, mean the total distance traveled. This is 480 meters. But 480 meters is not the actual value, because we ignored this part. We didn't include this part. So we didn't include this part. It means the distance traveled is more than 480. Actual distance traveled is more than 480. So the first option is not possible because this is less than 480, and this is not possible because this is way big. So this is not possible. This is also not possible. So the answer should be close to 480. So the best approximation in this case can be B, and B is our right answer. So this is how you can approach this type of problems. I hope this one is clear to you. For question number 7, we need to find out what is definition of linear momentum. And linear momentum, simply we understand P is equal to mv, means the momentum is the product of mass and velocity. Because momentum is a vector quantity, so we need to say velocity instead of speed. So in this case, if you look at option 1, force per unit time, this is not definition of momentum. Product of force and time, this is impulse, so this is also not momentum. This represents change in momentum, or simply we can say this is impulse, force time, impulse. So this is also not momentum. Product of velocity and mass, this is definition of momentum. So this is representing momentum. So our answer for this one is C. Velocity per unit mass, this is also not momentum. So the answer for this question is C. Pretty straightforward one. Simply you need to understand momentum is equal to product of mass and velocity. For question number 8, it is given to us a mass of 0.20 kg is suspended from the lower end of a light string. Light string means that string has no mass. A second mass of 0.10 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium, and then the thread is cut. Then this thread is cut. We need to find out immediately after the thread is cut, what is upward acceleration of 0.20 kg mass. So first of all, we have this arrangement, and this is in equilibrium. So this is given to us, this is in static equilibrium. Static equilibrium. So it simply means that we can simply find out the force in the spring, and we can draw the free body diagram. If we draw the free body diagram, in this case, the force acting downwards, that will be equal to the weight of these two masses, and that is 0.20 plus 4.10 times 9.81, and this one has to be equal to the spring force. So we can draw the spring force that is acting vertically upwards. You can also imagine that we can close these two masses in a box. So you can see now the mass inside this box is 0.20 plus 0.10 kilograms. So we can say spring force in this case will will be equal to 0.2 plus 0.1. So simply we can say this is 0.3 times 9.81 newtons. And this spring force is acting vertically up. Now it is given to us this thread is cut. It means this mass has been removed. So we can redraw this setup again. So we can redraw. So we have spring here and there is only one mass that is attached with this spring. And that mass is 0.20 kgs. Now we need to understand when we just cut the thread, at that moment, in that very short interval of time, Fs will not decrease. Fs will be equal to this value, means its value will not decrease. For a very short period of time, Fs will be equal to 0.3 times 9.81 and this is value of Fs. And the force acting downwards, that has been decreased and that force will be equal to 0.20 times 9.81. So in this case there is a resultant force and resultant force is acting vertically upwards because the greater force Fs is greater than weight and that is up. So in this case acceleration also will be acting vertically upwards and we need to find out value of this. In order to find value of A, so simply we need to use Fnet. Fnet will be equal to ma and the mass of the system in this case is only 0.20. So we can use this formula. Fnet will be equal to Fs minus this force. So Fnet is equal to 0.3 minus 0.20 times 9.81 and this is equal to mass of the system. Mass of the system is 0.20 times A and from here we can find out value of A. So A will be equal to 0.3 minus 0.2. This will be equal to 0.1 times 9.81 divided by this mass and mass is 0.20 and if we solve this one our final answer will be 4.9 meters per second. So this is how you can approach this problem in a beautiful way. When we just cut the thread, spring force will take some time to adjust itself. So that's the reason spring force will stay same at that moment. So that's the reason we have said this force is equal to 0.3 times 9.81 and then you can figure out. I hope this one is clear to you and the answer for this question is A. If you have any questions you can leave in comments. For question number 9, it is given to us a snowflake and a raindrop are in still air. They both fall from west at the same time and from the same height far above the ground. The snowflake and raindrop contain the same mass of water. Assume that there is no evaporation or melting. Also assume that for a given speed, the drag force acting on snowflake is greater than drag force acting on the raindrop. So here, one thing we need to understand, they have the same mass. They have the same mass and the same height, but the drag force on snowflake is greater than drag force on raindrop. We need to find out which statement about the snowflake and raindrop is correct. So the best way is we can simply draw here. Imagine that this one is snowflake and we can also have a raindrop and imagine this one is the raindrop. They have the same mass. So we can write down here first of all, they have the same mass, both of them, they have same mass, they are dropped from the same height. So we can write down same height, but drag force Ft is greater for snowflake, is greater for snowflake. So these things are very important. We will be using these informations to answer this problem. Now we need to understand, in this case, snowflake mass is the same. It means the weight is the same. But this one will experience greater drag force. Drag force is greater for this one. So the Fnet we can find out. Fnet for this one, Fnet will be equal to ma. So the Fnet is weight minus the drag force. So this is drag force and this is equal to ma. Now from here we can see A will be equal to W minus Ft divided by M. So if drag force is greater, it means that if this force is bigger, it means the average acceleration will be lower. So this is one thing we need to understand. So we will say the acceleration of snowflake S will be lower than acceleration of raindrop. So I'm just using R for raindrop. Acceleration will be lower. Now we can also compare the velocity. V is equal to U plus AT, but in this case they have initial velocity 0, so we can simply say V is equal to AT. Now we need to understand comparison between time. Snowflake, as the drag force is greater, so it will take shorter time to reach terminal velocity. Because it will take shorter time because the drag force is greater, so drag force will balance the weight quickly. So we can say drag force balance weight quickly. Drag will balance weight quickly. Will balance weight quickly. So we can write down will balance weight quickly because the value of the drag for snowflake is greater. Balance weight quickly. So it means in case of snowflake, time taken to reach terminal velocity will be shorter. So for snowflake, we can write down the terminal velocity Vs. This is equal to As and this is equal to Ts. But in this case, we have seen that Ts is also shorter than Tr. Raindrop will take longer time to reach terminal velocity because drag force is small, so it will take longer time for the drag to reach same magnitude as magnitude of weight. So Tr will be greater than Ts. So from here simply we can conclude now that as this one will be smaller, this one will be shorter, so it means Vs for the snowflake will be smaller, lower terminal velocity for snowflake. We can also sketch this one. So imagine that we have in this case V against T graph. So if we sketch first of all for the snowflake, let's say this is for snowflake, it reached terminal velocity. We can say this is for snowflake, so it reached this terminal velocity. But if we sketch this one for the raindrop, raindrop will take longer time and its acceleration also will be greater, so maybe it reached terminal velocity somewhere here. So this is the terminal velocity. So this one will be for raindrop. Acceleration of raindrop greater because this gradient has to be higher than the snowflake and it will take longer time, so it will reach higher terminal velocity. I hope this one is clear. So now you need to use this understanding and you need to answer the question. Let's try to understand this concept with the help of demonstration. Imagine that we have two papers. One, this is A4 size paper, is full paper, and this is also A4 size paper. So I will fold this one. I will just fold this one like this. So this is like a raindrop and this one is like a snowflake. If I drop both of them from the same height, so which one will reach the ground first? I hope you will say in this case raindrop, because raindrop will reach a higher terminal velocity and it will be moving faster. If the distance is the same, this will reach the ground first. So this one will reach the ground first. So you can see here now, you can do this demonstration by yourself. So if I drop now, you will see raindrop means this folded paper. This one will be moving faster and this paper means the snowflake. This will be moving slower. Its terminal velocity will be slower. Its terminal velocity will be higher. So you can look at this demonstration. So you saw in this demonstration that raindrop reached the terminal velocity, higher terminal velocity means was moving faster and reached the ground first. Mean it took shorter time to reach the ground. So simply we can write down in this case, raindrop will take shorter time to reach the ground. Shorter time to reach the ground. So let me write down here, shorter time to reach the ground. Shorter time to reach the ground. Shorter time to reach the ground because it has higher terminal velocity to reach the ground. So raindrop, so this is we are talking about raindrop. So it will take shorter time to reach the ground because its terminal velocity is higher. Now let's try to find out answer. For option A, it is given to you the raindrop takes more time than the snowflake to reach terminal velocity. Yes, that's true because raindrop drag force is lower at any given speed, so it will take longer time to reach the terminal velocity and its terminal velocity will be higher. So this one is possible answer. So this can be the answer. Now if we go to this option B, raindrop takes more time to reach the ground? No, it takes shorter time, as you have seen in demonstration. For part C, they reach same terminal velocity? No, raindrop terminal velocity is higher, so this is also not possible. They take the same amount of time to reach the ground? No, raindrop take shorter time. So answer for this question is A. I hope this concept is clear to you. For question number 10, it is given to us two trolleys are held together on a horizontal surface with a compressed spring between them. When they are released, the trolleys lose contact with the spring. The trolley of mass 2 kg moves to the left at a final speed of 2 meters per second. How much elastic tension energy was stored in the spring? So in this case, we need to understand the elastic tension energy stored in the spring will be converted into kinetic energies of these two trolleys. For this question, we have the speed of trolley of mass 2 kg. Speed of this one is given, so this goes to the left. So we can say speed of this one is v1, and that is equal to 2 meters per second. And the speed of this trolley we need to find out. Let's say speed of this trolley is v2. So we need to find out v2. So in this case, we need to understand, as initially this system is at rest, so the momentum of this system is 0. And momentum has to be conserved in this case because there is no net external force acting on this system. So the P initial has to be equal to P final. Initial momentum is equal to 0. So in this case, we will take to the right as positive. To the right as positive. So the momentum of this one is positive and momentum of this one is negative. So we can write down 1 times v2. This momentum is positive, plus we need to add momentum of this one, and this momentum is negative because the velocity is negative. Now from here we can figure out this is v2, and here we have minus 4. So from here we can find out v2. This is equal to 4 meters per second. So this is the value of V2. Now we can calculate total kinetic energy. So we can say total KE after. So we can say total KE after, total kinetic energy. So that will be equal to 1/2 m mass of this one. We have 1 kg, and the speed of this one is 4. So we have 4 squared plus kinetic energy of this trolley. If we have mass that is 2 kg and the speed is also 2. So if we simplify this one, in this case we will get this is 8, and in this case we will get 4. So the kinetic energy is equal to 4 joules, and kinetic energy is equal to elastic potential energy. So EPE in this case will be equal to 12 joules. So this is how you can figure out answer for this problem. So the answer for this one is D. That's all for today's video, and a lot more videos will be coming very soon. If you really want to develop your understanding of physics, I have uploaded a lot of videos on my channel. You can find at least 350 videos. If you watch those videos carefully, your concepts will be very clear. And also, if you have any questions, you can leave your questions in comments, and I will be answering as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 1, Variant 1. And in today's class, we will start from question number 11. We have already discussed from question number 1 to question number 10 in part 1. So for those questions, you can search for October-November 2022, Paper 1, Variant 1, Part 01. And you can find a detailed solution about question 1 to question 10 in my previous video. The video we uploaded yesterday. And in today's lesson, we will start from question number 11, and we will try to discuss from question number 11 to question number 20. Means next 10 questions in this session we will discuss. And as always, we will discuss these questions in detail so you can improve your conceptual understanding and you can have better understanding about these questions. The main goal of these videos is to help you to improve your conceptual understanding so you can have better understanding of physics, and next time you can handle questions with confidence. Let's study together. Let's improve together. For question number 11, it is given to us a square board of side length X hangs freely from a nail P as shown in the figure. The board has uniform thickness and is made from material of uniform density. A second square board of side length 2x is made of same material and has the same thickness as the original board. The second board is then hung from a nail Q. Nails P and Q are at the same height. We need to find out what is the vertical distance between the positions of the centers of gravity of two boards. So first thing in this case we need to understand is that when you hang any board freely, the center of mass always lies below point of suspension. You can simply understand from here. Let's say this is the marker. If I let it go, means this is hanging freely. When it will stop, its center of mass will be right below the point of suspension, means the point where I am holding this marker. So it will lies right below point of suspension, means when its moment is 0. So this is pivot point and center of mass has to be right below this one. So the line of action of the force will pass through the pivot, so there will be no moment. So point of suspension always above center of mass, or simply you can say center of mass always lie below point of suspension. So this is first point you need to understand. If you have understanding of this one, now simply we can draw the line. We can draw the line from point of suspension to other end. So it means center of mass is on this line. And same we can repeat for this second board, and in this case you can see the center of mass will lie on this line. Now we need to find out the location of center of mass. And let's say the length of this line, red line, let's say this one is equal to small l. We can take this is small l, and for this one we can say this is capital L. And center of mass will be halfway. So we need to find out first of all what is value of L. So if you look at this side, these two sides, you can see this angle between these two sides, angle is 90 degrees. And if you look at these two sides, you can also see this angle is 90 degrees. It simply means that this is a right angle triangle. So as this is a right angle triangle, so simply we can say in this case L square will be equal to x square plus x square, and L in this case means L square, this will be equal to 2 times x square. So from here we can find out value of L. L will be equal to root of 2 times x. So this is value of L. So simply we can say this is equal to root of 2 times x. And now we try to find value of capital L. So capital L you can also do in the same way. This one will be equal to L square. L square will be equal to 2x square plus 2x square. And from here we can write down this will be equal to 4x square plus 4x square. If we add these two together, we will get this is 8x square. And here we have L square. We need L, so we have to take square root on both sides. So this will be 2 root of 2 times x. So we have value of small l and also we have value of capital L. Now we need to find out the value of center of mass. I mean the distance from here to here. This distance we need to find out. And that distance will be L by 2. So in this case, we can say LCM. LCM. So means we are saying this part. LCM. And LCM will be equal to L by 2. So in this case, this is equal to root of 2 times x. And here also we can say LCM small up to the center of mass. So we can say this is small LCM. And this will be equal to root of 2 times x divided by 2. And this one we can write down. This will be equal to x over root of 2. Root of 2. Now we need to find the difference between these two. Means we need to find out LCM. LCM minus small LCM. Difference between these two. So we have LCM, that is root of 2 times x, minus we have x divided by root of 2. Now from here, how we can write down, this will be root of 2 and root 2 multiplied with root 2, we will get this will be 2x, and here we will get x. And finally, this one will be equal to x divided by root of 2. And this is our final answer. So this is how you can approach this problem. And this is a beautiful way to answer this kind of problem. For question number 12, it is given to us forces are applied to a rigid object. The forces all act in the same plane. In which diagram is the object in equilibrium? So first of all, let's try to understand what is meaning of equilibrium. When we say object is in static equilibrium, it simply means that resultant force in any direction. We can simply say net force in any direction is equal to 0, and also the net moment about any point is equal to 0. It means the clockwise moment about any point has to be equal to counterclockwise moment. Now simply we can say net moment is equal to 0. Net moment is equal to 0. So simply we can say net moment about any point has to be equal to 0. Now this is what we need to figure out. But before we answer this question, let me tell you this question is from May-June 2016, paper 1-1, means paper 1 variant 1. So this is a repeated question. The same question, 100% same question you will see in 2016 paper 1 variant 1, same question. Now let's try to answer this question. In order to answer this question, if you look at option A, in this case we will write down first of all F net. Is F net is equal to 0 or not? In this case F net is equal to 0 because the downward force is F and upward force is also F, so it means F net is equal to 0. Now we need to find out, is the net moment in this case, is it equal to 0 or not? Net moment. So if you look at this point, let's say we take moment about this point. If we take moment about this point, in this case you will see net moment due to this one will be 0. Moment due to this one, this will be clockwise. So this moment will be clockwise. And moment due to this one, this will be anti-clockwise, and they are the same because force is the same and distance of the force from the pivot also is the same. So it means clockwise moment in this case is equal to anti-clockwise moment. So simply we can say net moment is equal to 0. So the answer for this question is A. So this is in static equilibrium. Now let's try to check option B, why B is not answered. So first thing we will look at net force in this case. So we have 2F acting down, 2F is acting vertically up, and there is no force along horizontal. So the net force in any direction in this case is equal to 0. But if you look at net moment now, let's say we take our pivot point here. So this is our pivot point. So we can take pivot here. So moment due to these forces will be 0, and moment due to this one, moment due to this one will be anti-clockwise, and moment due to this one also will be anti-clockwise. So the net moment will not be equal to 0. So in this case, net moment will not be equal to 0. So it means this is not in static equilibrium. We can go to next now, and also we can take our pivot in this case at this point. F net in this case is not equal to 0 because 2F is acting up, 1F is down, so F net is not equal to 0. So we can say F net is not equal to 0. But moment, net moment is 0 because due to this one, this moment will be clockwise, and moment due to this one, it will be anti-clockwise. So the net moment is 0. So we can say net moment in this case is equal to 0 because forces have the same magnitude and the distance, perpendicular distance from the pivot is also the same. So the net moment is equal to 0. Now if you look at this option, in this case we can also take our moment about this point. So you can see net force is 0 in this case because 1F is acting vertically down and 1F is acting vertically up. So the net force is equal to 0. But net moment is not equal to 0 because moment due to this one, this is anti-clockwise, and moment due to this one, this is clockwise. These two moments, they will cancel each other, but there is still net moment due to this force, and this one will be counterclockwise. So this will be anti-clockwise. So in this case, net moment is not equal to 0. Net moment is not equal to 0. So this is not equal to 0. So that's reason B, C, and D, they are not possible answers. So the answer for this question is A. And this is a typical type of question. You need to understand how to handle this type of problems. For question number 13, it is given to us a rod XY has negligible mass and the length of the rod is 75 centimeters, as you can see here. The rod is suspended from a fixed point P by a string attached to end X. So as you can see here, this is end X and it is suspended from this point P. And this is string. And string is also massless. So string is massless. It is also given to us an object of mass 11 kg is suspended by a string. So this is also a string is attached to the rod at a distance of 25 centimeters from end X. So the object is attached here with this rod. We need to find out which vertically upward upward force acting on end Y, means on this end vertically upward, so mean this force has to be vertically acting upward, so we can say this force is F. On end Y of the rod would hold the rod horizontally in equilibrium. So this rod has to be in equilibrium. As it is given to you, the rod is in equilibrium. It simply means that you need to use conditions for equilibrium to find the answer. So we have two conditions. First condition, net force in any direction has to be 0. The second condition, moment about any point has to be equal to 0. Means the net moment about any point has to be equal to 0. So we can use net force concept, or we can use net moment concept, and we can answer this problem. So we need to use a smart way to answer this problem. The smart way is we can take moment about end x, means we can place our pivot here. So if we take moment about this end, net moment has to be equal to 0. So moment due to this one, this moment will be clockwise, and moment due to this one, this will be anti-clockwise. So this will be clockwise and this moment will be counterclockwise, and these two moments has to be equal to 0. So in this case, simply we can say moment due to this one, we have mass that is 11 kgs, and we need to multiply with 9.81, and distance in this case is given to you. This is 25 centimeters. You don't need to convert this one into meters. You can solve without that, because centimeter on both sides will be cancelled. If you are not very clear, you can multiply this one with 10 to minus 2, but it doesn't matter. And on other end, we have force F and perpendicular distance that is 75 centimeters. So this is 10 to negative 2. Now simply you can solve for F. If we solve this one for F, our answer will be about 36 newtons. So the answer for this question is C. So this is how you can approach a very straightforward question if your concept about equilibrium is clear. A lot of static equilibrium questions can be answered based on this concept. Means two conditions you have to use. Net moment about any point has to be 0, and net force in any direction has to be equal to 0. Sometimes we can use only one condition, we can answer problem. Sometimes we have to use both of them to find the solution. So this is the only way to answer this type of problems. For question number 14, it is given to us the density of water is 1.0 grams per cubic centimeter and density of glycerin is 1.3 grams per cubic centimeter. Water is added to a measuring cylinder containing 40 cubic centimeters of glycerin so that the density of mixture is 1.1 grams per cubic centimeter. Assume that the mixing process does not change the total volume of the liquid, and we need to find out what is volume of water added. Before we answer this question, let me tell you, this question is from May-June 2018, paper 1, variant 2, question number 10. You will see the same question in May-June 2018, 100% same. So it's very important that you go through past papers before your final exam. So maybe some of the questions will be repeated and you will be more confident to answer those questions. So it's very good practice to do past papers before your final exam. So let's try to answer this question now. For this question, it is given to you. Density of the mixture is this one. So we can start with the best way to answer this type of problems is, first thing, you can write down mass of the mixture. So in this case, I will be using capital M for mass of the mixture. And mass of the mixture, this one has to be equal to mass of the water plus mass of glycerin. So beautiful way to answer this type of problem. Always start with mass of the mixture, and that one has to be equal to mass of water and mass of glycerin in this case. So what is mass of mixture? Mass of mixture will be equal to density of the mixture plus volume of the mixture, and volume of the mixture will be equal to volume of water plus volume of glycerin. So we can simply write down in this form. And mass of water will be equal to density of water times the volume of water plus density of glycerine times volume of gas. Now simply you need to plug in values. That's all. This is the main idea. Rest is just you need to simplify calculation. That's all. Now in this case, density of mixture is given. We can write them simply. This is 1.1, and we have volume of water. This is what we need to find out. But the volume of glycerine is given. That is 40. So you can write down this is 40. Plus density of water is given. That is 1. And volume of water you need to find out. So this is VW. Density of glycerine is given. That is 1.3. And volume of glycerine is given. That is 40. Now we can simplify. So here you will get this is 1.1 volume of water. Plus you have 1.1 times 40. So we can draw these brackets. And here we have volume of water. And here you have 1.3 times 40. We need to find out in this case volume of water. So we can rearrange for volume of water. So for volume of water, we can write on here this is 1.1 VW, and here you have VW means you can take this one on left side and this one we can take on right side. So here it will be 1.3 times 40 minus you have 1.1 times 40. From here we can take VW common. So you will VW, if you take common from here, you will get this is 1.1 minus 1, and here you can take 40 common. So you will get 1.3 minus 1.1. Now we can further simplify and we can find out value of volume of water. So from left side we can say VW, this is 0.1, and from right side we have 40, this is multiplied by 0.2. So VW in this case simply is 40 times 0.2 divided by 0.1. So if we cancel here, we can say this is 2. So the 40 times 2, this is simply equal to 80. So our answer for this question is D. So this is 80. And we are using cubic centimeters. So volume is 80 cubic centimeters. So this is our final answer. So this is how you can approach any question. Mean the same type of question about mixture. You can use this technique. And the best way is to start it with mass. And then you can go to the second step and you will be able to find the answer. I hope this question is clear to you. Let's move on to next one. For question number 15, it is given to us a box in the shape of a cube falls from a ship into the sea. The box lands with its lower face level with the surface of the sea. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. As the box sinks, the lower face is always parallel to the surface of the sea, which graph best represent the variation of the upthrust acting on the box with depth of its lower face below the surface of the sea. So beautiful question on upthrust. So first of all, let's try to understand when it is just at the surface, So in this case, it is not inside the water. So it is just at the surface. So we can simply say box on the surface of the sea. So this is given to you. Box is at the surface of the sea. So we can draw this one here. You can see this one in a very clear way. So just at the surface. So you can see it is just at the surface. So this is not inside. So this is not inside water. As it is not inside water, it means there will be no upthrust. So no upthrust. What is upthrust? Upthrust actually, this is upward force and this is equal to weight of fluid displaced. So this is equal to weight of fluid displaced. So we can write down weight of fluid displaced. So this is the main concept you need to understand. Weight of fluid displaced. So very important to understand what is upthrust. And upthrust, let's say this is U, and upthrust will be equal to the density of the fluid times G times volume of fluid displaced. So this is volume of fluid displaced. So volume of fluid displaced. Now let's try to understand. When it is at the surface, there is no volume of fluid displaced. I will say volume FD, volume of fluid displaced. As this one is equal to 0, so the upthrust is equal to 0. Now we need to understand how upthrust is depending on depth. So we can little bit write down in a better way so we can understand how upthrust is linked with depth. So we can say rho F T, and the volume of fluid displaced. So we can write down this one in form of volume of the cube. Volume of cube inside water. So we can say that will be area, cross-sectional area, means the cross-sectional area, this cross-sectional area, times H. H is the depth inside water. So from here you can say U is directly proportional to H, means is directly proportional to depth. So it is directly proportional to depth because density of the fluid is constant, G is constant, and cross-sectional area of cube is also constant. So it's directly proportional to H. And upthrust will go on increasing until this box, I will simply draw here one small box, until box is fully submerged, means it is inside the water. Upthrust will increase, means upthrust will increase when depth is equal to 0 to depth is equal to H. Depth is equal to 0 to depth is equal to small h. Is equal to small h. In this case, we are saying small h, the height of the box. The height of the box. After that, upthrust will be constant because after that, you can see the volume of fluid displaced. This will stay constant. G constant, density of fluid constant. So upthrust will stay constant. So anywhere inside this water, upthrust on this cube will be same. So after h, upthrust has to be same. So now simply you can find out the answer. I hope you will simply say, in this case it is telling you upthrust go on increasing. That is not possible. Upthrust always stay constant. That is also wrong. Upthrust increase up to depth is equal to h. After that this is constant. This one is right. So this is the point when it is fully submerged. We can also say when fully submerged. Fully submerged. When it is fully submerged. So this is the point when it is fully submerged. After that, upthrust will remain constant because volume of fluid displaced. This will be same. G is a constant. Density of fluid is constant. So upthrust will stay constant. So this is the answer. But this is not possible. This one is not possible because these two quantities are directly proportional. So this one is not possible. So the answer for this question is C. Very nice question. For question number 16, it is given to us a spring is compressed by a mass as shown in the figure. Which statement describes the changes to the energy of the spring when it is compressed by the mass? Now, first thing we need to understand, in this case, when this spring is compressed, its gravitational potential energy will decrease because its center of mass will go down. So we can take a reference point. So we can take this reference line. Here we can take h is equal to 0. The height is equal to 0. So the GPE at this point is equal to 0. So when spring is compressed, its height of center of mass will decrease. As height of center of mass will decrease, so we will say GPE in this case will decrease because height of center of mass of the spring that will go down. As this will go down, GPE will go down. Now the next thing we need to understand, how about elastic potential energy? When spring is compressed, elastic potential energy, we need to understand EPE. This is equal to 1/2 kx squared. So when the spring is compressed, x will increase, mean the compression will increase. So as compression will increase, its EPE will increase. So it will store more and more elastic potential energy. Here elastic potential energy is equal to 0 because x is equal to 0. So we can say in this case EPE is equal to 0. So we can say EPE is equal to 0. Why EPE equal to 0? Because compression in the spring is equal to 0. So simply you need to understand for this question, GPE will decrease because center of mass of the spring will decrease, and EPE will increase because compression in the spring will increase. So we can use this understanding and we can find the answer. For option A, it is given to us spring gains gravitational potential energy. This one is wrong. It lose actually gravitational potential energy. So A is not the answer. Spring gains gravitational potential energy. This is also wrong. It lose. This is wrong. The spring loses gravitational potential energy and also loses EPE. This one is wrong. It gains EPE. So C is also wrong. If you look at option D, spring loses GPE and gains hence EPE. So this is the right answer. So this is simply you can answer pretty straightforward question if you have some understanding about GPE and EPE, elastic potential energy. For question number 17, it is given to us a man of mass 75 kgs runs up a staircase consisting of 30 steps. Each step is 20 centimeters high. The man takes a time of 7.0 seconds to run from the bottom of the staircase to the top. What is the average rate of increase of gravitational potential energy of the man? So very straightforward question. Simply this is asking you to calculate rate of increase of gravitational potential energy. So first of all, we can calculate in this case gravitational potential energy. The change in gravitational energy means delta GPE, the change in gravitational potential energy. That one will be equal to mass of the person times the change in height. And we need to calculate rate of increase. So we can divide this one by time. So we can say delta GPE means the total change in gravitational potential energy. If we divide this one by total time taken, we can calculate rate of increase of GPE, means the average rate of increase of GPE. Now in this case simply we need to plug in values. So this is the rate of increase of GPE. In this case mass of the person is given, that is equal to 75 kgs, and G is constant, that is 9.81. Height we need to find out. One step is 20 centimeters high and there are 30 steps. So 30 times 20 centimeters means 0.20 meters. Just divide by 100 and divided by time taken. Time taken is 7.0 seconds. Now if we solve this one, our answer will be 634 because this is rate of increase of joules per second. So this is our final answer. So the answer for this question is 6. For question number 18, it is given to us an alpha particle has 2.2 times 10 to negative 13 joules of kinetic energy, and we need to find out the speed of alpha particle. Very straightforward question, just based on kinetic energy concept. So simply we can write down in this case kinetic energy will be equal to 1/2 mv square, and we need to find out speed in this case. So speed will be equal to 2 times of kinetic energy divided by, so let me write down this kinetic energy in a proper way so it will look a little bit nicer. So we have 2 times ke, and this will be divided by m, and if you take root of this one we can calculate value of speed of alpha particle. So in this case we have kinetic energy of alpha particle, that is 2.2 times 10 to minus 13 and divided by mass of alpha particle. And mass of alpha particle, we need to understand alpha particle consists of 2 protons and 2 neutrons. So the mass of alpha particle is equal to 4u, and 1u is equal to 1.66 times 10 to minus 27 kgs, and you can find the value of atomic mass unit in data. So it simply means that the mass of alpha particle is equal to 4 times 1.66 times 10 to minus 27 kgs, and we need to replace m with this. So this is mass of alpha particle. So simply if we write on here 1.66 times 10 to negative 27 and we take root of this one, we can calculate speed of alpha particle, and speed of alpha particle in this case will be equal to 8.1 up to 2 SF times 10 to 6 meters per second. So this is value of speed. So the answer for this question is C. Very straightforward question. For question number 19, it is given to us identical springs are joined in 4 arrangements. Which arrangement has the same spring constant as a single spring? So first of all, we can imagine a single spring. So imagine that we have a single spring. So this one is a single spring. So this is single spring. And let's say we apply force on this single spring and it is extended by certain amount. So we can say it is extended by this amount. Extension in this one, let's say, is equal to x after applying force F. So we can say when we apply force F on this one, it is extended by this amount. And let's say spring constant of this one is K. Now we need to look at given options. If you look at given option, in first case, let's say the force force here. The force here is F. When the force here is F, force acting on this spring also will be F. Force acting on this spring also will be F. So the extension in spring 1 will be X. Extension in this spring also will be X. So it means in this case, K will be equal to F divided by total extension, that is 2X. Means K new, in this case we can say this is K new. So this will be K divided by 2 because K here is equal to F by X. So this is half. The value of this K will be half, means this spring will be more flexible. Now if you look at this arrangement, in this case again we apply the same force F. So the force on this spring will be F by 2 and spring on this force also will be F by 2. Means force will be divided into two parts. As force on this one is half and force on this one is half, so extension also will be half. So the extension we will say in this case this will be Kx by 2 and here extension will be also X by 2. So now we can find out the value of spring constant. So we can find out K nu. So K nu in this case we have the force and extension in this case is total force and total extension. So this is X by 2. So in this case we have K nu, that one will be equal to 2F by X. So we will get this is 2 times of K, means spring in this case is more stiff because it has higher value of spring constant. And now we can go to the next one. So in this case again we apply force F. So in this case the force on this one will be F by 2 and force on this spring also will be F by 2. Force on this spring acting will be F by 2. These springs are massless, so force on this spring also will be F by 2. Now if you look at extension of this spring, extension of this one will be X by 2, extension of this one will be X by 2, and extension of this one also will be X by 2, extension of this one will be X by 2. So what is the total extension? Total extension will be X by 2 plus X by 2 means X. So we can find out K nu in this case. K nu will be equal to total force divided by total extension. Total extension in this case we have X. So it simply means that K nu, this is equal to K. So this one is right answer for this question. So this one is the answer. So it means C is the right answer. So let's try to understand this part D as well. If you look at D, for this one we have force F that is acting here. So we can write on force F. So force on this spring will be acting, force on this spring will be F, and force acting on this spring will be F by 2. Force acting on this spring also will be F by 2. So the extension in this spring, extension in this spring will be X by 2. Extension in this spring also will be X by 2. Extension in this spring will be X. So we can find out value of K nu. K nu will be equal to the total force divided by total extension. So in this case total extension we have X plus X by 2. So it means this is 3X by 2. Or simply we can say this one will be equal to 2F divided by 3X. 2F divided by 3. So this one is K nu. Or simply we can say this one will be equal to 2 by 3K. So this is how we can find value of K for this arrangement as well. So this is how you can approach this problem. I hope this one is clear, and answer for this question is C. You can also understand when the springs are connected in parallel. So this is another way to answer this problem. You can simply use formula if you're not clear with concept. When springs are connected in parallel, they are like resistors connected in series. Means the K effective in this case will be equal to K1 plus K2. And when springs are connected in series means like this, they are connected in series. K effective is like resistors connected in parallel. This one will be equal to 1 over, so this will be equal to 1 over K effective equal to 1 over K1 plus 1 over K2 and so on. So these springs are connected in parallel. So this is connected in parallel. They are connected in series. You can also use the formula. You will get the same result. And and in this case these two are in series, these two are in series, then they are connected in parallel to each other. So these two are in parallel, this one is in series, and they are connected in series with each other. So you can also use these formulae. Later you can try by yourself and you will get the same answers. If your answer is different, you can leave questions in comment section and I will answer. For question number 20, it is given to us an unstretched spring has a length of 2.0 centimeters. The spring is then stretched within its limit of proportionality by a tensile force of 1.5 newtons. This is the maximum force. The elastic tension energy stored in the spring is 0.045, means 0.045 joules. What is the stretch length of the spring? So the best way to answer this problem is we can sketch. First of all, when the spring is unstretched, so this is unstretched. Let's say this length is equal to L naught and the value of L naught is given to us. We can say this is L naught and value of L naught is given 2.0 centimeters. Then we apply force on this spring and this spring is stretched, so we can draw here, and question is asking us to calculate this length. Let's say this one is equal to L1, but we can calculate extension in the spring, means delta L we can calculate, delta L we can calculate. So how we can calculate delta L? Because elastic potential energy is given to us, so we can say EPE, this is given to us, and this one will be equal to average force time delta L, average force. So we have F max, that is equal to 1.5, and initially force will be 0 divided by 2 times delta L. So here we have delta L. So simply we are using this formula, don't get confused with this. EPE simply is equal to 1/2 F, but this F is maximum. Why we use 2? Because we need to find the average force acting on the spring. So I have written this one so you can have better understanding, not just memorize formula. So this is 1/2 F max time max, F max. So EPE in this case is given, so that is 0.045. So from here we can find out delta L. Delta L will be equal to 2 times 0.045, and this one will be divided by 1.5. So if we solve this one, our final answer will be equal to 0.06 meters, or simply we can say delta L in this case will be equal to 6 centimeters. But we need to calculate L1, and L1 is equal to L naught plus delta L. So we need to calculate value of L1, stretch length, mean the total length of the spring. L naught we have 2.0 centimeters, this is 2.0 centimeters, and delta L is 6.0 centimeters. So this is in centimeters. So our final answer in this case will be equal to 0.8 centimeters, and this is the total length of the spring after we apply force on this. Stretch length means the total length. So this is total length. So this is how you can answer, and we are done for today. We have done from question 11 to question 20, and in tomorrow's video we will solve next 10 questions. See you in next video. Bye for now. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on waves from October-November 2022, Paper 1, Variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding and you can have better understanding of these questions. Let's study together. Let's improve together. For question number 21, it is given to us a signal generator, amplifier, and loudspeaker are used to produce different sound waves in a room. The relationship between the properties of these waves are investigated. Which relationship is not correct? Which one is not correct? And that one will be our answer. If you look at option A, it is given to us amplitude is proportional to wavelength, but there is no any relationship between amplitude and wavelength. So it means this option is incorrect. So this one is incorrect. So this one can be our answer. So this one can be the answer. If you look at option B, it is given to us frequency is inversely proportional to wavelength. So we can find out this one from wave equation, means equation for speed of a wave. V is equal to F times lambda, and from here we can make F the subject. So we can say F over lambda. So from here we can see that for constant speed, of a wave, we can see f is inversely proportional to wavelength. So it means this option is correct. So this one is correct. Intensity is proportional to amplitude squared at a given frequency. Yes, this is also true. Intensity is directly proportional to amplitude squared if frequency is constant. Frequency is constant, means the frequency of the wave, if we keep constant and we increase amplitude, it means intensity will increase. And for the option D, it is given to us time period is equal to reciprocal of frequency. This is also true, means time period is equal to 1 over f, mean this option is also correct. So our answer for this one is A, because A is incorrect and we need to find out incorrect option. So the answer for this one is A. So this is how you can figure out. And also you need to understand intensity. If frequency is not constant, if frequency change and we keep amplitude constant, how intensity will change? Intensity is directly proportional to frequency square if A is kept constant. So if A is kept constant, so then intensity is directly proportional to frequency square. And this one you need for intensity. This point is a very important one. For question number 22, it is given to us when a guitar string is plucked, it causes longitudinal sound waves in the air, as shown in this figure. The speed of the sound in air is given, that is equal to 340 meters per second, and we need to find out approximate frequency of sound waves. So how we can find out frequency of sound waves? Speed of sound waves is given, so simply we need to understand V is equal to F times lambda. We need to find out frequency, so simply this will be equal to V divided by lambda, means divided by wavelength. And in this case we have value of V, that is equal to 340. So if we can find out value of lambda, then we can figure out value of frequency. So if we look at these waves, means longitudinal sound wave in this air, we can see in this region, if we look at this region, particles are compressed. So in this region, as particles are compressed, we call this region is compression. And in this region, you can see particles are away from each other. So this region is called rarefaction. And again here you can see in this region, particles are compressed. So this region is also compression. So we can say this is also compression. And the wavelength for longitudinal wave, this is the distance between two consecutive compressions or rarefaction. So in this case, we can find the distance between two consecutive compressions, and that distance will be equal to 1 wavelength, lambda. And this distance in this case is equal to 0.5. So lambda is equal to 0.5 meters. So we can write down value of lambda here. So this is 0.5 meters. Now just you need to simplify. So we have 5. This is divided by 10. So we can say this is 340 divided by 5 multiplied by 10. So we can cancel this 10. So we will get 2 here. And so the final answer in this case is 680 hertz. So this is value of frequency. And this is how you can figure out. This question is quite straightforward one. So the answer for this question is B. For question number 23, it is given to us a transverse wave travels along a rope. The diagram shows the rope at time t is equal to 0. The wave is traveling from left to right. The period of the wave is capital T. One particle of the rope is labeled X, which graph shows the variation with time t of the displacement of particle X between t is equal to 0 and t is equal to 2t. So the particle is at this point, so it's labeled X. Now you need to understand how this particle will move. Wave is moving from left to right, so we can draw this wave for the next instant of time, means after short period of time where the wave will be. So for that purpose, simply you can take the points. This point will go forward, this part of the wave will come here, this part of the wave, this will come a bit forward, this part of the wave, it will come forward. So simply we can draw the wave. So it will come forward here, and this will move forward and so on, and this one, this will move forward, and this one also, the peak will move forward. Now we can connect these points, so we can see the wave will be at the next instant of time. So this is in a beautiful way you can connect that. So this is how you can connect. Now you can see from here, this particle at point X, this is moving down because it has to follow the wave, so this will go down. means this particle will go down, and this particle is at equilibrium, so it will go down and it will follow the wave. Or in a very simple way you can understand, particles follow coming wave. In a very simple way, if you even don't draw this one, you can understand the motion of this particle. Particle follows coming wave. Particle follows coming wave. Coming wave. If you look at this particle, if we draw this line here, this part of the wave has already passed. So the particle will follow the coming wave. So if you look at the coming wave, you see particle is here, so it will follow this wave. So it will go down, then it will climb up, then it will go down. So we can also draw like this. Then it will go down, then it will go up, then go up, then go down. So like that. So the shape we will see. The particle means will follow. Let me draw with red line. So this is, you will see the displacement of particle with time. How displacement of the particle will vary with time. So from here to here, this is one after one period of time, and from here to here, this is after another period of time. Meaning 2t, its motion will be like this, its displacement will change like this. So this is one way, a simpler way to do this one. Otherwise, simply you can draw this wave and you can see. So in this case, if you look at option C and D, so that is not possible because the particle is starting from equilibrium. So we can simply eliminate these two options. So these two are not possible. Now if you look at option A, this is also not possible because the particle from equilibrium, it will go down. So this is going up. So this is not possible. So the best possible answer for this question is B. Means first of all, particle go down. So you can see from here. Try to compare these two. I will be using different color now to give you some feelings about that. So you see in this case this go down. So here you see this goes down. It reaches this point. After this point it go up. You can see this will go up. And after that it go up and then come down to equilibrium. So you can see this part here. And after that it go down to the lowest position. So this go to the lowest. Then it go up to equilibrium. So you can see this goes to equilibrium. And then it reaches crest. This also reaches crest. And after it come back to equilibrium. So it has completed two cycles. So this is how you need to understand this type of problem. Very simple way. Just look at this one. Particle follows coming wave. If particle is here, means particle is here, it will follow the coming wave. If particle here, for example, where this particle will go, this will go up. So this will be the part of the wave. Mean this will show the variation of displacement with time and so on. I hope this one is clear to you. So this is how you can answer. So let me explain you this one in a little bit different way so I can clean these things. So let me clean this all. So we can clean this one. So let me draw this wave again. So let me draw this wave to give you some better feelings about that. So I can redraw this wave. So in a simpler way, I can just draw this wave. So this is the wave. Now I can move this wave forward. Now I can simply select this wave. So this wave, simply I can select and I can move this forward. So you can see here, if I move forward, you can see how the particle motion will change. So this is how wave is moving from left to right. So in this case, you will see that this particle will go down. This particle go down, and particle here, this particle will go up. Particle here, it will climb up, and the particle which was here before at the top, this particle will go down, and particle here, you will see that one will go up, and so on. So this is how you need to answer this type of problems. I hope this makes sense to you. You can see what is happening. Now let's say if this wave is, for example, is moving to the left, moving to the right, we can also understand that part. Let's say this wave is moving to the right, so we can take this wave. You see, first of all, this wave is here. If this is moving to the right, so this is what will happen. Now this particle will go up. Because it will follow this wave. So this is what you need to understand. I hope this makes sense to you. For question number 24, it is given to us a jet aircraft travels at a speed of 0.80 v and v v is the speed of sound. The aircraft directly, very important, directly approaches a stationary observer. The frequency of the sound emitted by the aircraft is 100 Hz. We need to find out which frequency does the observer hear. So this is a typical question about Doppler effect. So in this case, simply we can also sketch. Imagine that this one is the aircraft. So we can say this is aircraft. So this is aircraft. Aircraft is approaching an observer and the speed of aircraft is 0.80 v, and stationary observer is standing here. So observer is at rest, mean v naught is equal to 0. And we need to find out frequency of the sound heard by observer. This frequency we need to find out, and frequency of the source fs is given, that is equal to 100 Hz. So this frequency is given. So simply it's just simple question about Doppler effect. So we can write down observed frequency. This will be equal to speed of the wave divided by speed of the wave plus minus speed of the source. In this case, observer is at rest, and you need to multiply this one with frequency of source, means the frequency of the sound emitted by source. So now we can simply plug in values. So f naught we need to find out. In this case, source is approaching. So let me write down it as source is approaching. So f naught has to be greater than fs because source is approaching. So now you can choose, it has to be a negative sign or it has to be a positive sign. F naught has to be greater, so this one has to be negative sign because this denominator has to be smaller than numerator. This has to be smaller, so this one will be higher. So if this denominator, this is lower, this one will be higher. So simply now we can plug in values. We have speed of the wave, mean the speed of sound, that is v, and this is divided by speed of the wave minus speed of the source, that is 0.80 times v, and this one has to be multiplied with frequency of source. So this is frequency of source, means the frequency of sound emitted by source. So this one we can simplify. We can write down this is v divided by v times 1 minus 0.80 multiplied by 100. So this we can be cancelled with this one. So here we will get this is 1 over, we will get this is 0.20 multiplied by 100, and if we solve this one, our final answer will be equal to 500 Hz. So this is the frequency of sound observed by observer. So the answer for this one is D. Very straightforward question. I try to explain you in detail so you can feel how to answer this kind of problems. Otherwise, just simply use formula and you can find the answer. Question 25 says a telescope detects and analyzes some electromagnetic radiation of wavelength 2 centimeters. We need to find out which type of telescope is it. Is it microwave telescope? Is it optical, radio, or X-ray? So we need to understand the type of wave this telescope is detecting, and then based on that we can also find out type of telescope. So first of all, let's try to understand the wavelength of electromagnetic radiation. In order to remember order of electromagnetic radiation, simply you can remember Granny's X box. Granny's X box, use volts in my room. Use volts in my room. And you can remember the order of electromagnetic radiations. So we will start from here. Room. This is R for radio waves. So these are radio waves. M for microwaves. So we can write down microwaves. I for infrared. So I for infrared. And V for visible. So this is for visible light. U for UV, ultraviolet. X for X-rays. So X for X-rays, and G for gamma radiations. So this is for gamma. Now let's try to understand how we can remember the wavelength of these radiations. Radio waves. For radio waves, you need to understand the wavelength of radio waves is 1 meter and greater than 1 meter, means is greater than 1 meter. And for microwaves, the wavelength is from 1 to 10 to minus 3 meters. And for infrared, this is 10 to minus 3 to 10 to minus 6 meters. We are talking about meters. And for visible, the wavelength of visible is from 8 times 10 to minus 7 to 4 times 10 to minus 7. And UV, the wavelength is from 3 times 10 to minus 7 to 10 to minus 8 meters. And X-rays, this is from 10 to minus 8 to 10 to minus 12. And the wavelength of gamma radiations is 10 to minus 12 and smaller than that, and smaller than that. So this is smaller than that. So if you can understand these range of wavelengths, you can answer most of the question, almost 98% question about electromagnetic spectrum in past papers. Now for this given radiation, wavelength is 2 centimeters, means this is 10 to minus 2 meters, and this one is in this range. So we have here 10 to minus 2. So it means this is microwave. So the answer for this question has to be A, because this is microwave, and telescope will be microwave telescope. Means the type of radiation is microwave and telescope is microwave telescope, because this telescope is detecting microwaves. So this is microwave telescope. For question number 26, it is given to us two waves of the same type overlap. When does the principle of superposition apply? So first of all, let's try to understand what is principle of superposition. Principle of superposition simply tells us when two waves meet and the resultant displacement of resultant wave is the vector sum of the individual displacements of waves. So simply we can say resultant displacement of resultant wave, or simply you can say resultant displacement is the vector sum of individual displacements, of waves, individual displacements of overlapping waves, and there is no condition for direction of wave, there is no condition for frequency of waves, and there is no condition for amplitude. So it simply means that if you look at option B, when the waves have same amplitude, you need to apply principle of superposition. There is no condition for same amplitude. Even the amplitude is different, still you can apply principle of superposition. Even the frequency is different, still you can apply. Even they are moving in opposite direction or they are moving in the same direction, still you can apply principle of superposition, because principle of superposition is simply how to find the resultant displacement at any given point. So simply you need to add waves. But waves traveling in opposite directions, this is condition for stationary waves, means when stationary waves will be formed. So this is for stationary waves, and this one is also for stationary waves. So these are the conditions for stationary waves. So when stationary wave will be formed, and this is also for stationary wave. So these are conditions for stationary wave, means when stationary wave will be formed, but not condition for principle of superposition. With the help of this principle, simply we can find the resultant displacement at any point. So principle of superposition always applies if waves are of the same type. So the answer for this question is A. For question number 27, it is given to us a stationary sound wave is formed in a tube of length L that is closed at one end. The diagram shows the positions of the nodes and antinodes of the stationary wave. So in this case, we have two nodes. So these are two nodes, and also we have two antinodes. We need to find out which graph shows the variation of the amplitude of the wave with distance x measured from the closed end of the tube, means measured from here. So here distance is equal to 0, and we have node here. So this has to start from 0. So it has to start from 0. Now we need to understand in this case amplitude, for example. Is amplitude is a vector or amplitude is a scalar? Amplitude is scalar quantity because this tells us maximum size of displacement. So you need to understand amplitude is scalar quantity because it tells us maximum size of displacement. So amplitude is scalar because this is the maximum magnitude, maximum size of displacement. So it's a scalar. So now if you look at these given options, we have two nodes, means displacement is equal to 0 two times. So if you look at this one, how many nodes we have? We have 4 nodes in this case. So this option is not possible. If you look at this one, we have in this case also 4 nodes. So this is also not possible. We have only 2 nodes. But if you look at option A, we have 2 nodes. So this can be the answer. This one also have 2 nodes. So this also can be the answer. But now we need to understand amplitude is a scalar. So it cannot be negative. So it is not negative. So the answer for this one is A. So the maximum size of displacement. So it just tells us the size. So size cannot be negative. So the answer for this one is A. Question number 28 says a wave on the surface of water passes through a gap between 2 barriers and is diffracted as shown in the figure. What happens when the frequency of the wave is halved? Means the frequency become half. So the wavelength will be double. So first of all, let's try to understand when significant diffraction takes place. Significant diffraction takes place. Significant diffraction takes place when the wavelength of the wave is approximately equal to the gap size. Gap size means this gap. This is the gap size. So when the wavelength of the wave, this one is the wavelength of the wave. When the wavelength of the wave is about equal to gap size, there is significant diffraction. And also we need to understand, if we, for example, this lambda, if we increase this lambda, but we keep gap size same, so in this case there will be more diffraction. And on other hand, for example, if we decrease lambda and we keep gap size same, so in this case there will be less diffraction. So these points we need to understand. So in this case there will be less diffraction. So in this case wavelength is increasing because frequency is decreased, so wavelength increased, so there will be more diffraction. So the answer for this question is B. More diffraction. Less diffraction, this is wrong. No diffraction, this is also wrong. The same amount of diffraction, this is also wrong. So the answer for this question is B. For question number 29, it is given to us interference fringes are produced using light from a double slit. The intensity of the light emerging from each slit is initially the same. The intensity of light emerging from one of the slit is now reduced. How does this affect the interference pattern? So first of all, we will just discuss 2 cases. We will discuss case 1 first of all. In case 1, it is given to us intensity is the same from 2 slits. So simply you can imagine these are the waves. They are coming from those 2 slits. They have the same amplitude. So when these 2 waves, they will meet and they will interfere constructively, we will get a super crest, means a bright maximum. So we will get this one. So this is when they interfere constructively. And when they will interfere destructively, means their phase difference is 180 degrees in like this. So we will see the dark fringe, means no light. So this is case 1 when the intensity is the same. From 2 slit, intensity same. So we can say same intensity. So this is same intensity. Now we can discuss the second case when intensity of 1 slit is reduced. So in this case we have 1 wave. This is the initial one, and the second one, its intensity has been decreased, means the amplitude has been decreased. So in this case, we will, when we add these 2 waves, we will get this bright fringe, but this bright fringe will be dimmer than this one. And so we will say in this case, this one is brighter. So first of all, it is brighter in case 1, and in this case, this is dimmer, means the bright fringes will get dimmer. Now we can go to the second case. For the second case, if we have this is 1 and the second one, this amplitude is smaller than the first one. So in this case, we will get some light. So we will get this one. So in this case, simply you can see. So here we have full darkness, fully dark. So we can say fully dark this one. So this one is fully dark, that this one is brighter. So this is the concept you need to understand in this way, in a beautiful way. I hope this is clear to you. So in this case, simply you will say bright fringes, they get dimmer, and dark fringes, they get brighter. So let's look at given options and try to find out the answer. The bright fringes and dark fringes become brighter. No, this is wrong, because bright fringes, this is the bright fringe. So if you want to write on here, so this is the bright fringe. We have here, this is bright fringe, and this one is dark fringe. So bright fringes get dimmer, so this is wrong. The bright fringes, dark fringes all become darker. This is wrong. The bright fringes become brighter. No, they become darker. Dark fringes become darker. This is wrong. The bright fringes become darker, become dimmer, and dark fringes become brighter. That's true. So the answer for this one is D. For question number 30, it is given to us a diffraction grating has 4.00 times 10 to 5 lines per meter. A beam of light of wavelength 589 times 10 to minus 9 is incident normally on the diffraction grating. What is the angle between the second order maximum and direction of incident beam of light? So this is a typical question about diffraction grating. Let's try to sketch and try to figure out how we can answer this. So first thing is, you can simply imagine, in this case, this one is diffraction grating, and we can also draw, in this case, screen. So this one, you can imagine that this one is the screen, and the source of light is placed here. So this is placed at the center. So we can say this one is source of light. So simply you can imagine this one is source of light. This is source of light. And from the center at this point, we will observe first bright fringe. So this is central bright fringe, or we can say this is central maxima. Fringe order is equal to 0. And here we will observe another bright fringe, and the order for this one is 1. N is equal to 1, first order. And here we will observe the second order bright fringe, and for this one will be equal to 2. And also in the lower part, we will also observe bright fringes, and for this one will be minus 1. Simply negative means this is in the lower part. So we will also observe another bright fringe, and for this one will be minus 2. Now this question is simply asking us, we need to find out angle between central maximum and the second order maximum. Center maxima and second order maximum means we need to find out value of this angle. This angle we need to find. In order to figure out this angle, simply we need to apply d sine theta. D sine theta is equal to n times lambda, but n in this case is equal to 2, so we will say n has to be equal to 2. And also we need to understand d is equal to 1 over n. So this is value of n is given to us, so simply we can replace d with n. So we can say this is 1 over n. So here we have sine of theta, and this is equal to 2 times lambda. In this case we will get sine of theta. This one will be equal to 2 times capital N times lambda. We need to find angle, so we need to take sine inverse. 2 capital N times lambda. Now we can plug in values. Sine inverse of 2 times n is equal to 4.0 times 10 to 5, and lambda we have, that is 589 times 10 to minus 9. Now simply use your calculator and solve this one. If you solve this, your final answer will be equal to 28.1 degrees. So this is value of this angle, and this is what you need to find out. Pretty straightforward question. Just you need to use this formula, and you need to understand what is d, what is n, what is lambda. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on electricity from October-November 2022, Paper 1, Variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding and also you can have better understanding of these questions and also electricity concepts. Let's study together, let's improve together. For question number 31, it is given to us a length of wire RS has a circular cross-section. At end R of the wire, the cross-sectional area is A. As you can see, at end R, cross-sectional area is capital A. At end S of the wire, the cross-sectional area is A by 2. So this is A by 2 at end S. Charge Q takes time T to pass through the end R of the wire. There is constant electric current in the wire. So this is very important one. Constant electric current. Simply you can also understand as they are connected in series, it means current is the same. So this is just one wire. So current will be the same. How much charge will pass through end S in a time interval of T by 4? Means if we look at this end for time T by 4, how much charge will pass through this end? Means through this end. For this end it is given to us. If you look at this end for time T, how much charge is passing through this one? Q in time T. Means if you just look at that end for time T, the charge passing through this end will be equal to Q. And if you look at this one for time T by 4, how much charge will pass through this end? We can say that charge, let's say, is Qs. And we need to calculate Qs in this case. So electric current is the same. So we can say I is equal to Q over T QT. And this ratio between Q and T, this one is constant. So this one is constant because it is given to you current is constant. So simply we can say in this case Q over T, this one has to be equal to Qs divided by T by 4. And we need to calculate Qs. So simply we can make Q the subject and we can rearrange. So here we will get Q times we will have this is T by 4 and this is divided by T. So if we rearrange, we can write down this one. This one will be QT divided by 4T. So T in this case we can cancel. This T we can cancel with this one. So simply we left with Q by 4. This question is pretty straightforward. Even I no need to do this all steps. I can look at this question, I can find out. Because if this time decreases by 4, this Q means the charge also has to decrease by 4. Because the ratio between these two quantities is constant. So the answer for this question is Q by 4. But I have explained you using all these steps. Because you need to understand concepts and you need to improve your conceptual understanding. Because this concept is not only useful here, you can use this one to approach different type of problems based on the same concept. So that's the reason I hope you have better understanding of this. Let's move on to next one. For question number 32, it is given to us a power supply is connected to a component by connecting wires of total resistance 4.9 ohms. The power supply has an output power of 36 watts and terminal potential difference of power supply is 12 volts. We need to calculate how much thermal energy is dissipated in the connecting wires in a time of 1.0 hour. So we need to calculate energy dissipated in connecting wires. So how we can calculate energy dissipated? Energy dissipated in the connecting wires, simply we can calculate energy I square R times T. So this is how you can calculate energy dissipated in connecting wires. But here we have value of R, means the resistance of the wires is given to us and the time is given to us. So if we can find out value of I, we can figure out value of E. So in order to find I, we need to look at power output of power supply and terminal potential difference. So I is equal to P over V. We are simply using this formula P is equal to V times I. Now we simply need to plug in these values. So power in this case we have this is 3.6 watts divided by 12. So we will get in this case 36 divided by 10, and this is divided by 12. So if we solve this one, we will get 3 here. So our final answer will be 0.3 amps, and this current we can use now, and we can calculate value of thermal energy. Current in this case is 0.3 and R is 4.9, and time is 1 hour, and 1 hour has 60 minutes and 1 minute has 60 seconds. So if we multiply this one, we will get our answer about 1588, around this value, around this one. So this is value of E, and the closest answer is this one, C, 1.6 kilojoules. So the answer for this question is 1.6 kilojoules. Up to 2SF we can write down. This one is 1600 joules, or we can say this is 1.6 kilojoules. So the answer for this question is C. For this question, it is given to us a copper wire is to be replaced by an aluminum alloy wire of same length and resistance. Copper has half the resistivity of aluminum wire. We need to find out the ratio between diameter of aluminum wire and diameter of copper wire. So we can make one small table first of all. So we can say for copper. So here we can write down for copper, and we can write down for aluminum. So we have aluminum wire on other side, aluminum. So for this one, it is given to you L, and these two wires, they have the same length, so we can say L. They also have the same resistance, so we can write down their resistance is also the same. And resistivity of copper is half. So if we take resistivity of copper is rho C, resistivity of aluminum has to be 2 rho C, double. And we need to find out the ratio between their diameters. So we can say the diameter of this one, let's say is DC, and diameter of this one we can say this is DAL, aluminum. Now as they have same resistance, so we can write down R, this one is equal to rho L by A, but we can replace A with diameter because we need to find the ratio between diameters. So we can say this is rho L by pi by 4 d squared. So we can write down cross-sectional area, this one will be equal to pi by 4 d squared. Now in this case we have R that is constant, L is constant, so we can bring L on this side. We can also multiply with this pi by 4, so here we will get this is pi by 4. So we left here with rho divided by d squared. So this side is constant, so we can say the ratio between resistivity and diameter for these two wires is constant. Now we will be using this one. So we have resistivity of copper wire divided by diameter of copper wire. This one has to be equal to the resistivity of aluminum wire divided by diameter of aluminum wire, square of this one. We need to find DAL divided by DC. So we can rearrange, we can say this is DAL square divided by, we just cross multiply, divided by, we have this is DC square. This one has to be equal to rho AL, and we will divide this one here. So this one is rho C. And density of aluminum wire is 2 times of density of copper as it is given here. And we have to divide this one by density of copper. So this density of copper we can cancel. Now we left with this is DAL square divided by DC square. So if, and this one is equal to 2. So if we take square root on both sides, we will get here this is DAL or DC, and this is our final answer. So we have taken square root on both sides, so we got this final answer. So answer for this question has to be A. And this is how you can approach this type of problem. A beautiful way, and you can avoid some kind of trivial mistake if you follow these steps. For question number 34, it is given to us 3 identical filament lamps P, Q and R are connected to a battery of negligible internal resistance as shown in the figure. The filament wire in lamp Q breaks so that it no longer conducts. What are the changes in the brightness of lamps P and R? So first of all, let's assume that EMF of this power supply is 9 volts. To just make it simple for you, we can do without numbers, but the purpose of using these numbers is to make it easy for you so you can see what is happening. So if this is 9 volt, and if we look at the resistance of these two resistors as they are connected in parallel, and if we compare that resistance with resistance of this single resistor, let's say the resistance of this resistor is capital R. So I hope you will say resistance of this combination will be R by 2. So we can redraw this circuit. So let me redraw this circuit to make this point clear to you. What is total resistance of these two? Means the R total of this combination. That one has to be equal to R by 2 because they have the same resistance and they're connected in parallel. So resistance will be half. And so if we redraw this circuit, so imagine that we redraw this circuit. So if we redraw this circuit, so in this case, let's say we have one lamp and resistance of this lamp is half. So this one is another lamp. So we have two lamps, means we have two resistors. If resistance of this resistor is R by 2 and resistance of this one is R. If this one is 9 volt and current is the same, so if we connect voltmeter V1, let's say across this one, so this is V1, and we connect another voltmeter, let's say across this one, this voltmeter is V2. So I hope you will say if the reading on this one is 3 volts, reading on this voltmeter has to be 6 volts because current is the same. If resistance is double, it means V is double because V simply is equal to I times R. So this value of V is 6 volt. Now it is given to us filament wire in lamp Q breaks, means this is not conducting electricity. So we can redraw circuit now. If we redraw this circuit, what we have now, we will have simply, this is our power supply. So this one is power supply and we have only two lamps now. So we have lamp P, Q is not conducting, and we have lamp R. So this is lamp R and they are connected in series now. So if we connect voltmeter across, this one is P, this one is lamp R. Now if we connect, let's say this is voltmeter V3 across this one and we connect voltmeter V4 across this, and EMF of power supply is still the same. In this case, I hope you will say they have the same value of potential difference. So the reading on this voltmeter will be 4.5 volts and reading on this one also will be 4.5 volts. So in this case, you can see for lamp P, I can say for lamp P, we can say for lamp P, potential difference for lamp P. So we can say reading will change. The potential difference across lamp P will change from V1 to V3, and for lamp R, we can say for lamp R, reading will change from V2 to V4. So you can see here in this case, we have first of all 3 volts. It increases to 4.5 volts. But in this case, we have 6 volts. It decreases to 4.5 volts. So simply you will say in this case this lamp will be brighter, so this one will get brighter and this one will get dimmer, so this one will get dimmer. Lamp P get brighter and R get dimmer, so the answer for this question is P. So this is a beautiful way you can answer. We can also do this question without numbers, so you can try this one using no numbers, mean without numbers, you will get the same result. I wanted to use numbers because I wanted to make it easier for you to understand. So the answer for this question is A. For question number 35, we need to find out which ratio has the same units as electromotive force. So first of all, we can understand what is electromotive force. Electromotive force is simply equal to energy transferred per unit charge. So we can write down this is energy transferred per unit charge. Energy transferred per unit charge. So this is how we define electromotive force, or simply you can say this is simply equal to E divided by Q. Now if you look at the first one, this is energy transfer, charge per energy transfer, so this is just opposite, so this is not possible. Charge per unit time, this is current, so this is also not possible. QOT, this is current, so this is also not possible. Energy transfer per unit charge, yes, this one is right. So this is the answer. Energy transfer per unit time, this is power, and this is also not possible answer. So the answer for this question is C. For question number 36, it is given to us a circuit consists of a battery, a voltmeter, and 5 fixed resistors as shown in the figure. The voltmeter reading is 0. What is the resistance of resistor capital R? So first thing we need to understand, voltmeter reading is equal to 0. It simply means that this is balanced Wheatstone bridge. So this is balanced Wheatstone bridge circuit, a typical type of circuit. Balanced Wheatstone bridge. As the reading on voltmeter is equal to 0, so it means this is balanced Wheatstone bridge. And for balanced Wheatstone bridge, you need to understand the ratio between these two resistors has to be the same as ratio between these resistors. We can replace these two resistors with one resistor. So you can imagine that this is in one box. So these two resistors, they are in one box. And we can say the resistance of that resistor, let's say, is equal to RT. So Wheatstone bridge, if it is a balanced Wheatstone bridge, then the ratio between 2 divided by 5, this one has to be the same as the ratio between this divided by this resistor 10. I hope from here you can simply see that RT from here, if we find out the value of RT, this one has to be equal to 4.0 ohms. So you can simply find out value of RT. So the value of RT is equal to 4.0 ohms. And in this case, we have two resistors. They are connected in parallel. And the total resistance of these two resistors is equal to 4. So simply we can say 1 over 4.0. This one has to be equal to 1 over R plus 1 over 8. And from here we can find out value of R. So we will say in this case we have 1 over 4.0 minus we have 1 over 8, then that is equal to 1 over R. So we can take LCM here. So we can take 8. So here we will get 2 means 8 divided by 4, 2 minus 1, and this is equal to 1 over R. So here we will get this is 1 by 8. So 2 minus 1, we will get 1. 1 by 8, this is equal to 1 over R. So from here simply we can say R is equal to 8.0 ohm. So this is how you can approach this problem, and this question is a repeated question. You can also see this one in other past papers. So this question is repeated question. So this is repeated. You can find this one in other past papers as well. So this is third repeated question in this paper. For question number 37, it is given to us a battery of electromotive force 6.0 volts and negligible internal resistance is connected to voltmeter and 4 other components as shown in the figure. The voltmeter is connected between points X and Y. The positive terminal of the voltmeter is connected to X and negative terminal of the voltmeter is connected to Y. As you can see here, positive is connected to X and negative is connected to Y. It is also given to us initially the resistance of each of 4 components is 1.0 kilo ohms. Which change on its own will cause the voltmeter to show a positive reading. Positive reading means that this potential has to be greater than this one. So first thing we can see in this case Vx positive reading. So let me write on here for positive reading on voltmeter. Vx has to be greater than Vy. So this is first thing you can understand. This reading has to be greater than this one. It means the potential at this point has to be greater than potential at this point. And it is also given to us each component has same resistance. So this one has 1.0 kilo ohms. This also have 1.0 kilo ohms, and this also has 1.0 kilo ohms. Resistance of this one is also 1.0 kilo ohms. If we connect voltmeters now, let's say we connect voltmeter V1 here, the reading on this voltmeter will be equal to 3.0 volts, and reading if we connect voltmeter V2 here, reading on this voltmeter also will be equal to 3 volts. And if we connect voltmeter here, let's let's say we connect voltmeter V3 here. Reading on this voltmeter will be equal to 3.0 volts as well. And if we connect voltmeter here, let's say we connect V4 here, reading on this voltmeter also will be equal to 3.0 volts. Now we need to understand, we want this reading has to be greater than this one. So we have two ways. One way is that the resistance of this one decrease. When the resistance of this one will decrease, potential drop across this one will go down. So this is one way. The second way is that resistance of this one increase. When resistance of this one will increase, potential drop across this one will increase. When potential drop across this one will increase, potential at this point will decrease. So we have two ways. So we can get positive reading on voltmeter. So I will be writing here. We have two ways. One, if V1 go down, then Vx will go up. So Vx will go up. So this will be more positive than this one. And this can be done if resistance of this resistor go down. So we can say if resistance of this resistor go down, then V1 will go down and Vx will increase. So this is one way. Second possibility we have, if resistance of this one increase, simply we can say if V3 increase, so the resistance of this one has to increase, so Vy will go down, mean it will be lower than 3.0 volts. Vy in this case will go down, so it will be lower than 3.0 because here will be more potential drop across this one. If potential drop across this one is greater, reading on this one will go down. So when V3 go up, let's say V3 increase to 4 volts, reading on this one will decrease to 2 volts. Means the reading here then will be 2 volts, and if they remain same, this is 3 volts, so there will be positive reading. So we have these two possibilities. Now let's look at given options and try to figure out answer. Decrease the temperature of thermistor. Decrease the temperature of thermistor. If we decrease the temperature of thermistor, it means reading of thermistor will increase. If temperature of thermistor go down, resistance of thermistor will go up. So this reading will go up. So it is not possible. This is telling us this reading will go up. So that one is not possible. So this reading will go higher then. So reading on this one will be negative. So that is not possible. So this option is not possible. Increase the resistance of variable resistor. If we increase resistance of this one, potential drop across this one will increase. So if V1 increase, this one will go down. And that is also not possible. So if this go up, this will go down. So reading will be negative. So it means this is also not possible. Now the next one, reduce the intensity of light incident, means this one. If we reduce the intensity, resistance of LDR will go higher. So we can say if light level go down, resistance of LDR will go up, and the potential drop across this one V3, this will go up, and the reading Vy will go down. Vy will go down, mean it will decrease. Let's say this decreases to 2. So reading on voltmeter will be positive. So this is possible answer. So let me explain you this one in a little bit different way. If we want, for example, this reading to increase, so V3, for example, this one will be equal to the resistance of LDR. We can say RLDR divided by resistance of LDR plus resistance of thermistor. And this one has to be multiplied by V0. We can say this one is V0. So if we want this one to increase, we have to increase this one. And if light level go down, this one will go up. So this reading will increase. So if light level go down, resistance of this one will increase. Potential drop across this one will be higher. So the reading at this point will go down. Potential will decrease here. As this one is lower than this one, reading on voltmeter will be positive. So this is the answer. Replace the fixed resistor with 5 ohm resistor. If you decrease the resistance of this one, if we decrease resistance of this one, in this case you need to understand this resistance is higher, so the potential at this point will decrease because V2 will go down. If we decrease the resistance of this one, V2 will go down, V1 will go up, and Vx will go down, and that also will give us negative value on voltmeter. So this is also not possible. So the answer for this question is C, and this is how we can answer. I have explained this one in detail. If I want to explain this question very quickly, I will simply go for this one. So resistance of LDR has to increase. When it will increase? When light level will go down, so V3 will increase, so Vy will decrease. So this reading will be lower than this one. Reading on this voltmeter will be positive. So I will answer this way. But I wanted to explain you in detail so you can have better understanding about this problem. I hope this one is clear to you. If you have any questions, please leave your questions in comments. I will explain you as soon as possible. For question number 38, it is given to us an alpha particle passes close to a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of alpha particle changes as a result of deflection? So first of all, let's try to understand a little bit about alpha particle. Alpha particle has 2 protons and it has 2 neutrons. So the charge on alpha particle, so we can say the charge on alpha particle is plus 2e. So when this alpha particle will deflect, you can imagine that here we have gold nucleus. So this is gold nucleus. Let's say this one is alpha particle and this is coming. When it approaches close to this one, it deflects by angle greater than 90 degrees. It goes this way. So in this case, charge will not change. So charge will not change. Nucleon number means 4. This will not change. Proton number, this 2, this will also not change. But momentum will change in this case because momentum is a vector quantity, and in this case, direction of alpha particle is changing. So it means its momentum will change, but rest of the properties will stay same. So simply we can say in this case momentum will change. So this is the answer. For question number 39, it is given to us a nucleus of uranium-238 decays in stages by emitting alpha particles and beta minus particles, eventually forming a lead-206 Pb206. How many alpha particles and how many beta minus particles are emitted during the decay chain? So first of all, let's try to understand alpha decay and beta decay, and then we will answer this problem. First of all, let's try to understand what is alpha decay. Let's say we have nucleus X, its atomic number is A, mass number, atomic number is Z, mass number is A, and it decays into another nucleus, let's say Y, by emitting alpha particle. So we have alpha particle. So in this case, the atomic number will decrease by 2 and mass number will decrease by 4. So this is what you need to understand about alpha decay. Let's try to understand beta decay. Again, consider we have a nucleus X, atomic number is Z, mass number is Z, and this decay into a nucleus Y by emitting beta minus particle. Beta minus particle in fact is electron. So here has to be electron anti-neutrino. So electron anti-neutrino has to be emitted in this case to conserve lepton number. So this is particle, this has to be anti-neutrino. So in this case you can see the proton number, this will increase by 1, but mass number, there is no change in mass number, and this is the point you need to understand. In this case, there is no change in mass number stays same. So now we can look at uranium. We have in this case uranium 92, it decays into Tb, so it decays into Tb, that is 82, and the mass number of this one is 206. As there is no change in mass number when beta minus particle is emitted, so from here we can find out how many alpha particles need to be emitted. So we have 238 minus 206, so we will get 32. So we can find from here number of alpha particles. So we can find number of alpha particles emitted. They have to be in this case 8, because in one alpha decay mass number decreases by 4. So it means there has to be 8 alpha particles. So now we can write down here alpha particles. So we have this is alpha particle, and here we have this is beta minus particle. So we can find the numbers. In this case, we have already found it has to be 8 alpha particles. So if 8 alpha particles are emitted, this has to decrease. So if 8 alpha particles are emitted, this has to decrease by 16. So it has to decrease by 16, means the proton number has to decrease by 16. But actually in this case, this is decreasing by 10. So it means there are 6 beta particles. So 16 plus 6, this has to be equal to minus 10. So this decreases by 10. So it means there are 6 beta particles emitted in this case, and there are 8 alpha particles. So we can rewrite here. So we have in this case beta minus particle, and beta minus particles has to be 6. Why 6? Because decrease has to be 10. So due to alpha, atomic number decreases by 16, so it has to increase by 6, and that one has to be due to beta minus particles. So our answer is 8 alpha particles and 6 beta minus particles. So the answer for this one has to be 8. And this is how you can approach in step by step in a systematic way. I hope this one is clear to you. So the answer for this question is 8. For question number 40, we need to find out which list of particles contains only fundamental particles. So first of all, let's try to understand what particles are fundamental particles. Fundamental particles simply means that it has no internal structure. So one thing you need to understand, when we say fundamental particle, means that particle has no internal structure, or simply we can say cannot be further subdivided. So this is first thing you need to understand. Cannot be further subdivided. So that particle we call is fundamental particle. Or simply you can say that particle cannot be divided. So we call it fundamental particle. Or you can simply say it has no internal structure. Now if you look at antineutrino, all neutrino and antineutrino, they are fundamental particle. So it means this one is fundamental particle. Beta particle, yes, beta particle also fundamental particle. But mesons, they are not fundamental particles, because mesons consist of quark and antiquark. Let's say up and anti-up quark. So it consists of 2 quarks. So this is not fundamental. So the option A is not right answer. Baryon, they consist of 3 quarks. So they are also not fundamental particles. Neutrino, fundamental particle. Positron, fundamental particle. Electron, fundamental particle. All leptons, they are fundamental particles. Neutrino, fundamental, but alpha is not fundamental particle because it consists of 2 protons and 2 neutrons. So this is not fundamental. Lepton, all lepton family, we have 3 neutrinos and antineutrinos. We also have electron neutrino, means electron, muon, tau, and the neutrino, and antineutrinos. All of them, they are fundamental particles. So leptons are fundamental particles. Quark is also fundamental particle. Positron, this also belongs to lepton family. So this is also fundamental particle because this is antiparticle of electron. So the answer for this question is D. So D is the right answer. And that's all for this paper. I hope you have some better understanding of this paper, and also you have improved your conceptual understanding of these topics.